All right, so our goal here is to find the electric field at point P due to these two charges, okay? And we're just going to follow these two steps, these three steps, right? We're going to find the magnitude. In this case, we got to use what? That E is equal to KQ over R squared, right? Then we're going to find the direction, right? And then we're going to, which in this case will be an angle, right? And then we're going to add things as vectors. We're going to do vector stuff. Okay, and then ultimately at the end we'll have to draw a picture of it. So let's save a little spot here. This will be our vector drawing space. We'll draw the picture there, right? All right. Okay, so let's figure out the magnitudes first. Okay, the magnitude of A. Actually, let's figure out the direction first. I think that's more fun. So remember that electric fields are toward negative charges, away from positive charges, okay? So the electric field of B is going to be away from B, and the electric field of A is going to be toward A, okay? And this is going to have, A is going to have a positive X and a negative Y. B will have a positive X and a positive Y, okay? So let's figure out those magnitudes. The electric field of A is going to be KQ over R squared, right? So 8.99 times, let's see, A is 3.2. Notice I'm ignoring the minus sign here because it doesn't give me better information, right? And then P is how far from A? It's 2 over 4 down, right? So really it's the square root of 2 squared plus 4 squared, but notice that R has to be squared, right? Well, the square and the square root annihilate each other, right? So you don't even need to do that. Okay, so let's see, let's do this. Okay, so I'm going to go alpha F1. I'm going to get that fraction thing going on. I'm going to go 8.99 E9 times 3.2 E minus 6 over 2 squared plus 4 squared. All right, let's see if we get this. 1438.4. And then we're going to have to figure out a direction for that. But let's figure out the magnitude of B first. Okay. Is equal to 8.99 E9 times, let's see, B, this is B right here, right? B is 4.4 times 10 to the minus 6th. There we go. And then that's over 2 squared plus 3 squared. So we are 2 over 3 down, 1, 2, 3 down, right? Okay, so alpha F1, enter 8.99 E9 times 4.4 minus 6, 2 squared plus 3 squared. And I'm getting 3042.8. Roughly, right? Newtons per Coulomb. Okay, now let's figure out some angles here. Okay, so to figure out the angle, I feel like we should change the pen color. This is like a radical thing here. Okay, so let's figure that out in red. So the components of A are this way and this way, right? And this angle right there is the inverse tangent of 2 over 1, or 4 over 2, right? Okay, so the tan minus 1, because I'm really finding this angle here, right? And I'm really finding this angle. Inverse tan of 1, 2, 3, 4 divided by 1, 2. So second tan of 4 divided by 2 is 63.43 degrees. That's with the x-axis, right? Below, right? Below the x-axis to the right. Just like that, right? Okay. And then let's figure out the components of B. So B, or the angle of B, right? So B's components look like this, right? That angle is, of course, the same as this angle right here, right? Because they're what, alternate interior, exterior? I don't even know, but that's like a thing. All right, so the angle, this angle right here is the inverse tan of 1, 2, 3 over 2. So tan minus 1 of 3 halves is what? What is that? This pen is like seizing up on me. The more I write, the slower this pen gets. Let's see, 56.31. This is up and right. This is above the x-axis. Right? Those are the angles. Okay. So now we're set. Now we can actually go and go back to our blue pen, right? I feel like the blue pen's more friendly. Red pen's like, whoa, I did something wrong. Okay, so the electric field of A and the electric field of B. Okay, let's do a little, we're going to add up type of stuff, right? Ooh, I feel so accomplished here. Okay, so A is 1438.4. And this guy is the one that's got a negative y component, right? So this is x component, this is y component. This guy goes to the right. It's a positive x because it goes to the right, and it's got a negative y. B has a positive x and a positive y. All right, so let's figure this out. And then the magnitude of B is 3042.8. Okay. So let's do A. Let's find the magnitude of A. I'm just going up arrow on my calculator to find it. Hit enter, right? Let's find the angle for A is 63.43. Is that right? Yeah. All right, there we go. Now both numbers are like the last thing. So this is, the angle is 63.43 for A, right? Okay, so let's see A. This is the opposite side. So I'm going to find this guy with sine. I'm going to find this guy with cos, since I have the angle with the x-axis, right? Okay, all I have to do is decide plus and minus, right? Okay, so let's see, cos. So I'm going to go 1438 cos of that angle, and this gives me my x, so 643.27. Right, and that's in the x direction, that's positive, right? The y component is going to be sine in this case, right, because it's the opposite of that angle, right? Okay, so I'm going to go 1438, boom. Sine of the same angle, boom. And I get negative 1286.54. Okay, and these are all newtons per coulomb, newtons per coulomb. All right, so now let's do B. B, the angle is 56.31. This is our magnitude, right? So let's go find those numbers. I'm just going up arrow on my calculator till I find the magnitude. There it is. And I'm going to just hit enter, and I'm going to find that angle at 56.31. There it is. So now those two numbers are the last thing in my calculator. Okay, these components are going to be positive. The cos is going to give me the x. So 3042 cos 56.31 is 1687.82. And then sine, let's do the same thing. Let's go 3042 sine 56.31, 2531.74, right? And now we're all set. I'm just going to add this and this. Okay, here we go. So 643, let's find that guy. So there it is. Plus 1687. This is 2331.1. 0. I'll go just 10, right? All right, that's newtons per coulomb in the x direction, right? And then let's add these guys up. Let's go the opposite of, and I'll find the 1286 one. Come on, baby. There it is. Plus the 2531. This up arrow thing has changed my life. And this is 1245.19 newtons per coulomb Y. All right, oh, wow, we've got all this room here to draw a picture of this thing, right? So let's draw a picture of it. We're going to go over and up. We're going to go up. And the vector goes like that. Don't laugh at my line. All right, so this is 2331.10. This is 1245.19. Okay, so this is going to be, of course, the hypotenuse of that, right? So let's do this. Let's go square root of 2331 squared plus the 1245 guy squared. 2642. So again, I'm just finding the hypotenuse, right? It's the sum of the squares of the sides. 0.82. This is like a ridiculous number. We only really have 3 sig figs, right? There it is, right? Okay, newtons per coulomb. And then this angle is going to be tan minus 1 of 1245 divided by 2331. Okay, so tan, second tan of that guy divided by this guy. That's 28.1 degrees. There we go. Ta-da. So just double check that most of the mistakes people make are they tragically make it like away from a negative charge or toward a positive charge, right? So just remember it's away from positive toward negative charges, right? Tragically, they'll count like 2 and they'll say that that's 4, but it's really 3. Little things like that, right? But most of the mistakes are just you drop a minus sign here. So just draw your components carefully and decide what they are. Okay, I think in this right here, I'm just going to draw a picture of a good dog. All right, good enough. Hopefully that helps, huh?